Okay, well, I hope. Too loud. Okay, we'll get this right one day. You have to write down the settings for each classroom. Okay, well, I hope you guys had an okay weekend doing data camp. Hopefully, a little bit of fun, a little relaxation, not just all work, right? Okay. Anybody watching the Olympics? No. Figure skating? Okay, all right, anyway. Well, it's happening, so. Okay, we'll look at more pandas stuff. So pandas is, again, kind of our primary way of interacting with data when we're working in Python. So because the data frame is probably one of your most important data structures, and you need pandas to work with data frames. And on Friday, we looked at this concept of an index in a data frame and how everything in pandas is done based according to the index. And so all series have an index, all data frames have an index, and if you're going to introduce a new series, it's going to match everything up based on the index and do all of its computations index-wise. Okay. In today's lecture, we'll take a look at pivoting tables, using this group by feature, and what the structure that kind of powers that is what's known as a multi-index. Okay, so I'm going to load up kind of our standard things. Pandas is PD, NumPy is NP. I started loading matplotlib as pyplot.pyplot as PLT. I don't think we'll actually use matplotlib today, but we'll introduce that. I've assigned one chapter this week for data camp. Okay, so normally it's like 3 this week, just 1. Okay, and it's matplotlib. And if you want to do more, you're always welcome to do more. And this data camp thing, I know whenever it's homework, it sucks a little bit of the fun out of it. But I do think data camp is a great resource, and you have access to the full premium product, which is normally like $30 a month or something. So take advantage of it. I think you get access through June. Okay, so you get access through the full product through June. With all that extra free time you have, right? So, but as you do complete courses and stuff, you get like a little certificate and stuff. And I don't know if anybody even actually cares about data camp certificates, but sometimes it feels good to just say like, hey, I completed all of these things, so at least I have a basic exposure to it, and really to demonstrate probably your mastery and your skill with it. You'll want to develop your own projects and things like that. Create a GitHub. This is all a tangent here, but if you're applying for internships and jobs and things like that, I recommend everybody kind of create a GitHub and then think of some kind of data analysis project. Use some of the tools and skills that you've learned, and try working through a data analysis. Make sure you also write about it, because that's important. Not just putting in code cells that just show plots or something, but your ability to kind of to reason about it and communicate what you've reasoned in your data is also very important. Okay, so anyway, let me introduce the multi-index here. Okay, so I'm gonna just start by taking some random integers. Okay, all right, 9 of them, and notice what I'm creating a series. So the values in the series are just 9 random integers, Okay, so I'm doing random int 10, meaning digits 0 through 9, and then I want 9 of these things. And then notice what's going inside the index. In the index, I have basically a two-dimensional array. It's 2 rows, 9 columns here, but so I got a 2 by 9 structure, multi-dimensional array as the index. Technically, it's a list of lists, but it's going to get kind of processed as an array. And you can see I got AAA, BBB, CCC, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. So what does this look like when you create the, when you look at the series that we've created here? So I've created the series. There's 9 random integers go in this column. These are the values. And as far as the index goes, we've got AAA, BBB, CCC, and it only just prints out the first value. Okay, so this is basically A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, and so we have this multi-level index. All right, and so if you ask what is the index, now we see it's a length 9 index. Each component in the index is a tuple of length 2, consisting of a letter A followed by some number 1, 2, or 3. A, B, or C followed by a number 1, 2, or 3. Okay, and so this is the multi-index, and when we have that, we can do stuff. Okay, now you can select values. All right, so let's look at this. So if I say I just want the values index B, index level B. Okay, so I can do data.location B, and so it's using the index. It's going to use the kind of that top level index, and it's going to just basically extract out this. It doesn't even bother printing out the B's because it's B for all of these things. So it's going to be 1, 2, 3, 5, 0, 0. Okay. If you want to select via the inner index, you can do that. And now this might feel a tiny bit strange, okay? But because it's a series, right? So we're not looking at a data frame. A data frame, before the comma, it's which row you're looking at, and after the comma, it's which column you're looking at. But here it's a series, so you're just kind of picking out something in there. So we have a comma here, but this comma indicates between the top level index, which is the letters A, B, C, and then the second level, or the inner index, which is the numbers 1, 2, 3. And so we're saying we want the 2, and so it's going to pull out this 8 here, the 0 here, and the 7 here, and it tells us, you got ABC 807. Okay, and if you ask, well, what is this? Okay, what is the type of this thing? These come back as series, okay, as one might expect. And if you look at the index, this index is exactly as it appears here. The index is ABC. You can take this series, which is put in, has 2 levels to it, okay, right? And we can unstack the values, okay? So currently it's arranged, all 9 values are stacked in one column, and we got A, B, C. And what we can do is we can kind of take this, we can basically pivot our data, right? And we're going to unstack the inner index so that the 1, 2, 3s kind of get spread out across columns. And so now we have a 3 by 3 data frame here. Right? So it has unstacked the inner index. So the row index is ABC, and now the column index is going to be 1, 2, 3. So if we ask, what is this after we unstack it? It gives us a row index of ABC. We ask our shape, we get it's 3 by 3. And then technically, if I ask for the kind of the names across the top, it'll tell me it's another index 1, 2, 3. Okay, if you ask to stack the data back up, you get back the original structure that we had. Okay, so the inverse operation of unstack is stack, and this is what we have. I don't know if some of you are also in 102A, and some of you are not, and whatnot. But have you encountered tidyr in R? So in R, there's something similar. In R, you've got pivot longer and pivot wider, and unstack and stacker are similar operations to. So unstack would be pivot wider, and stack would be pivot longer, kind of conceptually there. All right, another option is doing what's called a swap level. Okay, so just so you can see it, unstack. I've unstacked it and I stacked it back up, so I get basically back the same thing. And so if we look at our numbers, it's 589500176. What I can do is I can swap the levels. Okay, it keeps, when you do swap levels, what's the change? It has made the outer index now the inner index, and the inner index the outer index. So the top level index is now the second level index, or I guess our level 0 index now becomes our level 1 index, and the level 1 index becomes our level 0 index. So we get AAA, BBB, CCC on the inside, and 123, 123 on the outside. And so when I do this, it preserves the original order of the data. And the dot location method, as far as selecting things, works exactly as we might expect once the data has been swapped. So if you want to select all of the A's, you have to indicate you want everything from the top level index, and you want everything at level A. Okay, and so here we get 5, 8, and 9 up here. Okay. What you can do is, after you swap the level, if you want your data values sorted based on kind of the new index, you can call sort index, right? Data.swapLevel, and then sort based on the new index. All right, and so now it's going to sort all of the 1s together, all of the 2s together, all of the 3s together, and then sort the next level ABC, ABC, ABC. All right, and so this rearranges our data. All right. Does all of this feel okay? All right, and then but when you do this swap level sort index, because these always return kind of copies of themselves, and so if I just say print data itself, it prints the original data set or series unaffected. Okay, the original series remains unaffected. All right, let me go ahead and give you your first view quiz answer for today, which is, I gotta pull this up because I don't remember, the letter B. B as in bear. B as in bear is your first view quiz answer. Okay, and so if I do a swap level dot unstack, what do I get? Well, I think this makes sense, right? So our first row will be 1, and then we're unstacking the inner index, so the inner index will become columns ABC, and we're going to get 551 across the first row. Second row will be 807. The last row will be 906. Okay, and we get a data frame of this. Okay, compare that to data.unstack, and these are basically transposes of each other. Okay, but that's because what we unstacked is the inner index. The inner index gets unstacked. So these are all kind of just little. I think I've chosen good examples, as long as you kind of take the time to look at them and make sure you understand what it's producing with each thing. Okay, so if you take a series and you call sum, it'll sum the whole series. So all of the values, all 9 of these values, if you sum them up, we get 41. But you can also call series by grouping it based on a certain level of the index. So if I say data.group by, right? So I'm going to group by the level 0 index, the first level, which is the ABCs. we can call dot sum on that, and it will give you the sum of everything A, sum of everything B, and sum of everything C. And then similarly, you can call group by the level 1 index. Okay, so which level of the index, and then dot sum there as well. Okay, I think. All right. I hope this makes sense. All right. Okay. So now that we've kind of established this multi-index thing, we can apply it to data frames and talk about reshaping and pivoting our data. Okay. So here, I've just made up this data frame. I've got just the numbers 0, 1, 2, 3, 4, 5. Okay. And one thing you'll notice is I've given the row index and the column index names. Okay, so a lot of times you'll just see the index and it'll be kind of just the row numbers or the row names and then just the column names. But here I've given inside the when I define the index for the rows, I say the name is going to be letter. And then, and when I define the index for the columns, I get name equals number. Okay, and so here we've got the row names. We got alpha, beta, and the columns 1, 2, 3. So I've given our rows, our column, and our row index names. And so if I just say take my data frame and I stack it, well, it's going to take the 3 columns and stack them into 1 column. Okay, so this is kind of like pivoting your data so it's longer, and I think this does. So I don't. In my mind, this is like, okay, this is very clear. It's very automatic, like what's happening. But I also recognize this might not be as clear for everyone else. So what it's doing is it's basically taking this row and it's pivoting it into 1 column, right? So these values are spread across 3 columns, and it's just going to take that kind of chunk and pivot it into 1 column here. And it's going to do this with these 3 values as well. It's going to pivot that into 1 column, and it stacks those 2 columns up. So we end up getting 6 rows. Okay, so this data is 6 rows, 1 column. It's a 6 by 1, but our index has basically 2 levels now. So what used to be 3 columns, these names 1, 2, 3 are now spread, or are now gathered into 1 column. So I've got a multi-index here. Okay, and then again, the stack and unstack are inverse operations. Okay, so unstack is kind of like take your multi-index and pivot it wider. Take these values which exist in 1 column and pivot them. Take these 3 values and pivot them horizontally, and so we end up getting back this 2 by 3 thing. Okay. Now this might seem a little interesting, but you can also specify the index to unstack. Okay. So by default, it's going to unstack the innermost index level. So we have an index at level 0 and an index at level 1. The index at level 1 is the number, and it's going to, by default, it's going to unstack the 1, 2, 3 into columns. So you're going to get columns 1, 2, 3. Now what you can also do is you can say unstack the level 0 index, which here is the letters. So I've got alpha and beta, and so this will establish 2 columns. Okay, the columns will be alpha and beta, and it's going to unstack the values accordingly. All right, so basically we're going to preserve the rows 1, 2, 3 like this, and then we're going to put 3, 4, 5 in the next column. And so this is going to be data.stack, and here I'm calling .unstack, and I'm going to specify the level of the index, the level 0 index, and so alpha and beta become the columns there. Right. And again, if you look at this, we've pretty much created kind of a transpose of this matrix, or of this data frame here. All right, and then if your indexes are named, you can also specify the the name of the index. All right, so here I can say unstack the index letter, okay, or unstack the index name number or something, and it will unstack. You can unstack by index name or the name of the level, not just the index level 0 or 1 or something like that. Okay. If your data has certain levels defined for some but not others, unstacking can end up producing missing values. Okay, so here I've got notice how I'm creating this. Okay, series 1 has values 0, 1, 2, 3, and index values A, B, C, D. Series 2 has values 4, 5, 6, and index values C, D, and E. And when I'm joining these together, I'm going to say I'm going to concatenate these two series. All right. So we remember concatenating things? Okay. So we're going to concatenate these two series, and then I'm giving, when I concatenate these things, I'm providing keys here. And so using the argument keys when concatenating the series will produce a multi-level index, and it's going to give kind of level 1 for this first thing and level 2 for everything else, right? So this is kind of useful if, let's say you have, I don't know, similar data across several months or something, okay? But they all come in like different worksheets or something, right? So like sometimes companies do this, right? They'll have like the January worksheet and the February worksheet and the March and whatever, and you kind of want to like combine them into one thing, but each worksheet looks exactly the same, so you can kind of provide this key, and you can say the first series is January, the second series is February, and Pandas will create a multi-level index, and this is what we get. Okay, so what is the shape if I call data2.unstack? What shape am I going to get? How many rows, how many columns? Data2.unstack. I wish you guys are sitting a little, I know it's like you're not supposed to sit closer, but then I would want you to like talk to your neighbor and confirm. But yeah, what do you think? Yeah, how many rows and how many columns? 2 rows, 5 columns. 5 columns A, B, C, D, E. 2 rows 1 and 2, and everything else will be, and it's going to fill in the values accordingly. So we get 0, 1, 2, 3, and then nan for 1E, and then we get values 4, 5, 6 for CDE in row 2, and nans for AB. Okay. Now, what happened here? Why did these values go from integers 0, 1, 2, 3? Right? It clearly says integers, 64-bit integers here, and now we see these decimal values. What happened here? Why did it go from integers to floats? Yeah. Because the nans got introduced, right? And so whenever you have nans in a series, nans are floats, and again, Pandas stores everything as NumPy arrays. NumPy arrays everything has to be of the same data type, and so if a nan appears, it's going to upcast from integers to floats, okay? Which in most scenarios is okay, although not always, because floats, there's a maximum integer value that you can represent. I think it's 2 to the 52, I think, is the biggest integer value you can represent, and beyond that, only certain values can be displayed. Or is it 2 to the 53? 2 to the 52 or 2 to the 53. One of those things is the biggest integer value you can represent. After that, it just starts dropping things. Whereas integers in Python, you can display as big as you want, and it'll do it. Okay. Here I called unstack, and I called stack it back up. All right. And so notice when I call unstack, I've got these nans. And when I call stack, it drops the nans. Okay, so I don't have a 1e, I don't have a 2a and a 2b here. Okay, now if you want to kind of preserve those, right, when you call stack, if you want to preserve the fact that some of these things are missing, you can call stack drop na equals false, and it will preserve those missing values here. Okay, so let's take a mini example of data wrangling, and so I'm going to load in this fake generated, not fake, this data set, and this is supposed to be U.S. macroeconomic data from 1959 quarter 1 to 2009 quarter 3, and I don't know, it's got all sorts of stuff. I was not an econ major. I don't know, are any of you econ majors? Okay, so you can tell us what all of these things, how they measure the economy, right? I mean, some of these things are clear, right? CPI, we use that to kind of measure inflation, I think, and stuff, like how much your products cost. But then there's like, I don't know, real personal consumption expenditures, real gross private domestic investment, billions of change, 2005 US dollars. Okay, well, anyway, such and such data has been gathered in our data set here. We've got 203 entries, so 203 rows. All of these things are floats, and we've got the year, the quarter. So these probably should be integers, but when we load in the data, we got 1959 quarter 1, 1959 quarter 2, 1959 quarter 3, so on and so forth. Okay. And apparently we've been measuring all of this stuff. So I call data.head gives us the first 5 rows. And what we're going to do is I'm going to generate an index, okay, a date-based index, and we're going to use this tool called, or a method called the period index. Period index. And so this kind of creates an index based on kind of time periods, and you can read all about this anytime you're dealing with, say, dates, and you're dealing with either like things like on a quarterly basis, monthly basis, even a weekly basis, and you want to kind of get dates and stuff like that. Okay, the dot period index is useful for generating that stuff. Okay, so here we're going to take from this data frame, we're going to set the period index. You can specify things like the year and the quarter. Other things you can specify are the month, the day, things like that. Oops. Right, and so I'm going to say take data.year, the year column, data.quarter. We're going to specify the quarter, and we're going to create kind of a name for this index that will be date. And so here it says now it recognizes this as period index 1959 Q1, 1959 Q2, and this it recognizes this as some kind of period index, and then we can kind of we can work with this. All right, so let's just create our own columns names, and we're going to take real GDP, inflation, and unemployment. So this is currently not attached to anything. Okay, this is just basically I'm just specifying a list, and these are just basically names that I'm going to be using. Okay, and we're going to just kind of take some of these things now. Now these, notice, so I got real GDP, inflation, unemployment. Okay, so I've taken kind of the names of those columns, and we're going to re-index our data. Right? So do you remember what re-indexing does? It conforms the existing data frame to this index that I've provided, and effectively, it's kind of like calling dot location if I don't have anything missing or anything like that. So basically, I'm just asking for these columns back. Okay, so real GDP, inflation, and unemployment. So this is what we get. Currently, because I didn't keep the original over here, when I brought in the data, okay, nothing has been specified as an index. I just have 0, 1, 2, 3, 4, and so on and so forth, okay? And I didn't bother keeping the year and the quarter, okay? But what I'm going to do is I'm going to just kind of take this quarter index that I've generated back here, this period index, 1959 Q1, so on and so forth. We have a tool. We can take our period index and we can call to timestamp, 2 underscore timestamp, and this will turn something like 1959 Q1 into a date, like 1959 January 1st. In 1959 Q2, the second quarter will be 1959 April 1. And then the third quarter is July 1, and the fourth quarter is October 1. So it's going to be the start date of each of these things. And these are all kind of optional as far as, you know, if you have a period, you can say, I want it based on the date, I want it based on some kind of other, the period index, let's see, the methods, okay, so you can call to timestamp on your period index, and you can specify the default is D, S otherwise, how you can specify start or end, which part of the period you want, okay? Right now, our index is just this range index starting from 0 and ending at 202. And so all I'm going to do is I'm going to just replace the data.index by replacing it with periods.timestamp. Okay, so I'm going to take this thing and I'm just going to replace the existing index. Okay, so this is not re-indexing. I'm just straight up replacing the index. All right, and I feel okay with this because this length is 203, this length is 203. So that'll line up. Okay, so now I can ask, okay, what does my data look like? And I get kind of, I think what I expected. I have 1959 January 1, I've got my 3 values. 1959 April 1, I got my 3 values. And we can take it, we can stack it up if I want, data.stack. But as it is, it's currently, this is a data frame, 203 rows and 3 columns. Any questions here? Does this feel okay? Just kind of this process that I did data wrangling. Let me go ahead and give you your second view quiz answer. Second view quiz answer today is A. A as an apple. A as an apple is your second view quiz answer. Okay. You can, so here, data.stack produces a multi-index, right, with a date level index, or multi-index with 2 levels. One level is the date, and the second level is the item, where we're tracking GDP, inflation, and unemployment. Okay. And if you want, after you do that, you can call reset index. And what reset index will do is it takes kind of your multi-index, or whatever index currently exists, is going to turn the index into columns. So the date and the item now become new column titles, headings, and it produces just a range index starting at 0. Okay, so here now I have a range index, and it goes 0, 1, 2, 3, 4. And then notice back here when I had the series, the values themselves didn't actually have a name. Okay, and just here's the date, here's the item. Or these were kind of the index names of the names of the multi-index. The values that we were actually tracking here didn't actually have a name, so it just kind of fills it in, gives it a 0 for the name there. Okay, and so if I ask this and I say, hey, what's this index? Now I've got 609 values. Okay, because I had basically 203 values 3 columns, and I stack them all up, 609. Okay. You know, if you wanted to keep this and you wanted to just rename, if you want to rename any of the columns, basically you call .rename, and you specify which thing you want to rename. You could also rename the rows as well if you wanted to. Okay, and you provided a dictionary of basically the old value or the old name, and you give it the new name. So here I'm going to say replace the old name, which was 0, and replace it. I did a search on that. Apparently, if you search 0, you get. Okay, well I don't know. I don't even know how to fix this because I've got my thing is blocking me from clicking the little X. Okay, well, this is my life now. All right. So I've got columns 0 is going to be renamed to value here. If you try to do unstack, okay, it doesn't work, right? And why doesn't it work? Is because unstack requires a multi-level index, right? And here I no longer have an index. I no longer have an index. Or I no longer have a multi-index. My index is just 0 through 608, okay? So here I had the multi-level index, and after I called reset the index, these became just regular old columns. My index starts at 0 and ends at 608, and so I can't call unstack on this. The unstack is powered by a multi-level index. All of this stuff of stacking and unstacking can also just be done directly using this function or this method called pivot. Okay, so here is my my data, L data. Okay, and so notice that L data, the way I have it right now, there's no multi-index. I could define a multi-index, and I could say, you know, take date as one level and item as another level. Or I could just call pivot on this, right? And so even though the original long data, that's what L data is, the long form data, which does not have a multi-index, I can basically perform this operation of unstacking in one step. Rather than having to redefine the index as a multi-level index, I can say pivot, okay? And we're going to pivot with date, item, and value, okay? So how does pivot work? You're going to provide the index, the columns, and the value names, okay? So here the new index is going to be made from the date column. Okay, so we're going to take this column date, and this is going to provide your new index. And then we're going to take the values in item, and these are going to become your column values. Okay, so we're going date, item, value, and then the values to populate will be the values. So here I'm pivoting from date, item, value. Okay, so the 3 values that showed up in the item column, which were inflation, real GDP, and unemployment, these become our new column headings. Yes. So value says, so what are the numbers that need to go in here? The numbers that need to go in here come from this column value. You could imagine another data set where I had a column for value, I had another column which had other numbers in it, right? Like I could, it could be date, real GDP, and it could be like, I don't know, value for California, and then a column for value for Texas, and a column for value for, you know, something like that. And then when you pivot this, now there's technically multiple values corresponding to 1959, January 1st, real GDP, right? And so when you do this, you can really only put one value in there. So what values should go in there, or which column should those values come from? And here, you know, we might say come from the California values, or come from the Texas values, or something. in our example, there's only one column of values, which it's like obvious what to do. But there you could have a data set where you have you're not quite sure which. I guess the computer wouldn't know which values you want to use to populate the thing. So that's what this is. So the documentation is here, and whoops, not that one, this one. Okay, index, column, and values. And you kind of can see this, and they've got a bunch of examples here as well for you to see how this pivoting stuff works. Pandas is very well documented. Okay, so over here I can do kind of the opposite pivoting. Here I can say the new index after I pivot, I want to be items: inflation, real GDP, and unemployment. And I want the columns to be the dates. And now I get this thing, right? So I get 1959 January 1, 1959 April 1, 1959 July 1 going across the columns. So here I'm saying pivot it based on this. You end up with 203 columns, and so Pandas just says, well, I'm going to only print some of these columns, and you get a dot, 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 and then going from 1961 to 2007. So we skip a few years there, but yeah, it basically gives you a little bit of glimpse of the front and the end there, so you can kind of see what happened. All right, and again, all of this stuff. So looking back at the original data, where I have the where it's in kind of this form, it still looks like this. So we had the long data, we had the original data, and all of that. Okay, I got a few more slides. Let me go ahead and give you your last view quiz answer for today. Today's last view quiz answer is D. D as in dog. D as in dog. All right, let's take a look at group by. All right, so here I have 4 columns, 5 rows, 4 columns. This is just a toy data set, so we can kind of see some of this stuff work. Okay, so no multi-index. Right now it's just 4 columns: key 1, key 2, data 1, data 2. My index is a range index 0, 1, 2, 3, 4. And so what we can do is we can call this group by, and this will kind of create like this internal grouping index that we can use. So here I can say, hey, take this data frame, df, okay? Let's look at column data 1, df data 1, and let's group it by key 1. Okay, so let's group by key 1. And so notice key 1, or the keys, I got A1, A2, B1, B2, and I also have A1 again, right? So I've got A1 appears, A appears 3 times, and 1 appears 3 times, and everything shows up once, except for A1. A1 actually shows up twice. I've got 5, 11, and 9, 16. And so I can say, if you group it by key 1, okay, we're going to have 2 groups, A and B, and we can say, what's the mean on this grouped data? The mean of 5, 11, and 9 is 8.33, and the mean of 12 and 8 is 10. So here we're just looking at column data 1, and we're grouping it by key 1. All right, so this is kind of like a t-apply in R. So in R you have t-apply, and then, or if you're using dplyr, it's got something very similar. You got group by just in dplyr as well. Okay, here's the data frame. You can just go directly. Okay, you can say data frame group by key 1. Okay, group by data frame key 1 dot mean. Okay, and so here, if you do that, it's going to say, all right, it's going to calculate the mean of basically anything numeric. So key 2. Pandas sees key 2s and says, oh, you got string data in there. The mean is useless for string data, so it just ignores the existence of key 2 entirely, and it just gives us the mean of the numeric column. So we get, if you group by key 1, the means of data 1 is this. If you group by key 1, the means of data 2 is this. Okay. here's the data frame again just for reference. You can also group by a multi-index, okay? So here I'm going to say, let's take data, the column data 1, and then we're going to have group by key 1 and then key 2. Group by, so notice inside the group by I have a list of columns. It's a list. The first item in the list is df key 1. Second item in the list is df key 2. So we're going to group by key 1 and then key 2. We do dot mean. It says, so we get, the mean of A1 is the mean of 5 and 9, 7. A2 is 11 and 5, so on and so forth. Okay. And then if you unstack, you get back this, which I think is what we expected. Again, here's the data frame for reference. Now, in all of these examples, we've been grouping by one of the columns that exists in the data frame. So I said key 1, group by df key 1, group by df key 2. Now, it's entirely possible that here you have this data frame, and then entirely separate, you've got some other series that provides grouping information. And you can group by that other series information. And so here I have just this entirely separate series called states with the names Ohio, California, California, Ohio, Ohio, and then another array somewhere else with these years, 2005, 2006, and stuff like that. And I can say, hey, group by the states and the years, okay, these other two arrays that exist. And we can do that, right? And so it just assumes everything's in the same order, that the order that you want. It's going to kind of line them up. Now, we could do this manually. And probably, for readability, you probably should just add the columns, to your data frame, append the column states, append the column years, and then you can kind of visually see it. But it's not necessary. You can just group by these other kind of arrays or vectors that exist and apply that. Okay, I'm out of time. I think you can kind of look over this on your own and see what happens. Here you can. There's other things. Here I've been calling mean frequently, but there's other functions. Basically summary, any kind of summary function, like how many values, size, how many, what's the median and things like that. Okay. When you do this group by stuff, it actually creates a tuple. It creates a tuple with things like that consists of the name and the group. And so here, just to kind of show you an example of what happens when you group by key 1, I've unpacked that iterable series of tuples, name and group, and I print out the name A. The group itself is this data frame consisting of just the values where the key is A. And then you can call additional functions like that, group.data1mean and things like that. Okay, so take a look at that on your own. All right, we'll end here, and we'll see you guys on Wednesday.